All right, so we're going to continue on with talking about parallel and perpendicular lines, and today we're going to take some time to review something you should have learned last year. We're talking about equations of lines. So that involves slope, graphing lines, and writing equations. Uh, yeah. So we have to, excuse me, we have to remember this and remind ourselves of this because on Monday we're going to talk about parallel and perpendicular lines, how they look in the coordinate plane, and about their slopes. So before we get to that, we got to remind ourselves and refresh ourselves of all this line stuff that you should have learned last year. Um, so it should be pretty easy today. I would think it's easy. Anyway, so let's start with a basic understanding of slope. So you can think of slope, and we usually abbreviate it with a lowercase m, as the steepness of a line. So how steep the line is, how much, like if it's kind of more flat, or if it's a really steep line, or if it is flat. So we can think of it that way. Now there's different ways to represent slope. So you're probably familiar with this phrase, rise over run. You'll probably taught that in middle school. Rise being how much you go up or down, run being how much you move left or right. Okay. You can also think about it, this is kind of fancy. We say this as delta y over delta x. Delta just means change, so you can think of this as the change in y over the change in x. And then what you're also familiar with is probably this, y2 minus y1 over x2 minus x1. Okay, so those are different ways you can think about slope. So now what we're going to do is we're going to just do two quick examples of how to find slope. And so one way is to do it from a graph like I've got here. And so usually there's going to be 2 points labeled out for you. And so we're going to calculate. And when I have the slope, I like to think about it as the rise over the run. So remember, the rise is how much you move up or down. And this line is going upwards from the left to the right. So that means my slope should be positive in the end. Okay. If it was running down, we would have a negative slope. If it's flat, completely flat, that would be a zero slope. And if it was straight up and down, that would be an undefined slope. So keep that in mind because you could see those. All right, so I like to start with the bottom one. You could really start wherever. And now I'm going to basically just count how far I have to go up until I'm eye level with the second point. So 1, 2, and right here that puts me at the same level as the other point. So my rise was 2. Now I'm going to run to the other point. 1, 2, 3. So this line has a slope of 2/3. You should remember that. That should not be new. All right. The other way you can do slope, one of the other ways, is I give you just 2 points. So we can define the slope of the line passing through these points. You could graph these two if you wanted to and do rise over run, or we're going to use this formula right here. So we're going to do the second y subtract the first y over the second x subtract the first x. So it says I was taught to start with the second one, so that's all I'm going to show you. So the second y is -4, and then always put subtraction, and then go to the first y. That's 1 over. Now we go back to the second x, 0, minus, always minus, go back to the first x, -6. Now we need to simplify if we can. So on top, we're going to get -5. On the bottom, minus minus makes a plus, so that is 6. If this reduced anymore, I would want you to reduce it, but it doesn't, so. Now, let's say you don't start with the second ones. You could start with the first y's in the first. Okay, let me show you what I'm saying. So let me divide it. I don't want to confuse you by me not talking correctly. Let me scoot this down. So instead of doing the seconds before the firsts, you could do it this way. Do the firsts before the second. So that would look like this. You start with the first y in the first point, 1, minus the second y, -4, over. The first x is -6. Subtract the second x is 0. Now see, it's kind of like backwards a little bit in reverse of what we had before. But we'll get the same thing, because 1 minus -4, that's secretly 1 plus 4, which is 5, over. -6 minus 0 is -6. So even though my negative's in a different spot, it's still the same answer, because that negative can kind of float wherever you want it to go. Okay? That's about slope. Now we're going to get into graphing lines. And before we get into actual graphing, I wanted to briefly go over the 4 different ways you could see a line represented. Everybody knows slope-intercept form. I can just say the words and kids will say it. Slope-intercept form, y equals mx plus b. Of course, we all know that m is the slope. And then b is the y-intercept. Specifically, it's an intercept, but it's the y-intercept. Okay, and on your homework, every answer, if you're asked to give an equation, it will be written in slope-intercept form, because that's the most common and the easiest way for us to do things with. So I want everything in slope-intercept. But another form of the line is called standard form. So that looks like ax plus by equals c. And so there's a couple things to note here. A, B, and C are integers, meaning they can be positive or negative, but no decimals. Okay? And then another stipulation is that A must be positive, always. I've seen it done where A is not positive, and that just kind of bothers me, so we're going to say A needs to be positive. B and C can be positive or negative, it doesn't matter. Point slope form, I really like this one because it's handy when you have in certain situations. So we will know the slope m and a certain point x1, y1. So we know those two things, we can use this form. Y subtract y1 equals the slope times x. Oops, that's a really bad x. X minus x1. So in certain situations, that's going to be helpful. And then lastly, there's vertical and horizontal lines. They're kind of the strange cases. So if you see x equals some number, 5, 14, 2 million, -4, whatever, this is the vertical line, meaning it's straight up and down. And this has an undefined slope. Okay, I'm not putting that because you should know it as undefined slope. If you see y equals a number, that is the horizontal line, and they are completely flat. Okay, obviously mine's not really flat, but you get the idea. A horizontal line has 0 slope. Okay, no steepness at all, it's just flat. Okay, so keep these forms in mind because they're going to pop up sometimes. Okay, let's talk about graphing. So I gave you some steps, general steps to follow. First thing you need to check is if your line is in slope intercept. If your line is already in slope intercept form, life's easy, you're good to go. If it's not in slope intercept form, you're going to have to convert it to get to slope intercept form because it's easiest to graph from slope intercept, okay? Once you have slope intercept form, then you have to plot the y-intercept first. So you'll go up or down the y-axis to wherever the intercept's at and put your dot. We will use our slope to build one more point, at least one more, because remember in Unit 1 we said that any 2 points can form a line. So the y-intercept will give us 1 point, and we can use the slope to find another one, and then we'll connect them. So hopefully we've done this before. I really hope you've done this before. I'm going to use a ruler to help me make everything nice and straight, but if you're at home, just freehand it. Okay. So graph the line y equals negative 3x plus 4. That is slope-intercept form, so I'm ready to go. My y-intercept is at 4, so I'm going to go up to 4 and put a dot. Okay, use my slope. My slope was negative 3. Well, slope is rise over run, so I need to know how far to run because this tells me how far I need to rise, which would be down. So if we think about it as negative 3 over 1, that'll help us figure out how much to run. So using the rise over run idea, this means from the y-intercept, we'd have to go down 3 and right 1 because that is positive. Okay, so down 3, right 1. And you could do it again. Down 3, right 1. If you want to get another point up in this area, you would have to do the reverse of this slope. So instead of going down 3, we would go up 3. And instead of right 1, we would go left 1. Okay, that's if you want another one up there. But really, you just need the y-intercept and one more point, and then you connect them. What? Sorry, my ruler was acting like it was stuck or something. And then because it's a line, we know lines are infinitely long, so we'll extend it and put our arrows. Okay. Graph the line y minus 2 equals 1/2 times the quantity x minus 4. Immediately I recognize that is not slope-intercept form. That is point slope. So I'm going to come down here and do a little converting. Y minus 2 equals 1/2 x minus 4. I need to essentially solve for y and get rid of this, so I'm going to distribute. Bring down y minus 2. That's going to be 1/2 x minus 2, because 1/2 times negative 4 is negative 2. Now I want the y by itself, because in slope-intercept form, y is by itself. So we'll add the 2. It's gone here, and coincidentally, it's gone here. So this line is just y equals 1/2 x. That's what I need to graph. So from here, if I wanted to write it out, my slope is 1/2. My b, there's nothing written out here. So we let the y-intercept be 0. That's the only time that, one of the few times that 0 is the answer instead of 1. Okay? So start with my y-intercept at 0. And then Slope is, they're both positive, so that means I go up 1, right 2. Up 1, right 2. Oops, I can't see. Up 1, right 2. If you want to go the reverse direction from the y-intercept, I mean, you got to do everything backwards. So instead of up, go down, and instead of right, go left. And then we can connect them. Okay. Not spending a whole lot of time on graphing, again, because you should know it already. Okay, I did want to include a vertical and a horizontal just so you could see it. So if we graph a vertical line, this number is where you're going to cross the x-axis. So we're going to go to 3 on the x-axis. And it's x equals, that means it's a vertical line. And so we simply just draw a vertical line that goes through 3. Just like that. Oppositely, we have y equals -5. That's a horizontal line. So we go down to -5 on the y-axis. And we draw. Okay? That's all there is to graphing. Now let's look at writing. Writing equations. This is one of my personal favorites to do for math. I don't know why. I just like it. Okay? Every equation that I want you to write, I want you to write it in slope-intercept form. So I want mx plus b as all our answers. And you'll be given various information to write the equation. Okay? So here we have a graph. And so if we want to do slope-intercept form, we need to first know the slope and then the y-intercept. I always like to start with the y-intercept because I think it's easier to find. So we're 1, 2, 3. We are crossing at 3. And then we need to calculate slope. So again, we're going to use rise over run. 1, 2, 3, 4 down. So that'd be a -4 on top over 1, 2, 3, 4. 1, 2, 3, 4, 5 to the right. So that'd be a +5. We have both those things, so now we simply just write them into the form. And there you have it. That's all there is. This one's even easier. I told you what slope was and I told you what y-intercept was, so you literally just plug everybody in. That is a horrible y. That's not much better, but it'll have to do. All right, this kind of problem. I like this kind of problem. Because all I've given you is 2 points. You have to first find the slope between the 2 points, and then second, you will pick one of those points and use point slope form. So let's see how to do that. So let's find slope. I'm going to start with the seconds, just like I was taught. So -4, the second y, subtract the first y over the second x, subtract the first x. And simplify. On top gives me -9. On the bottom will give me +12 because that's plus. 9 over 12 will simplify to -3 over 4. Okay, so I just found my slope. Now I'm going to use the point slope form because remember, all I need is one single point. I got 2 to pick from, so I can pick whichever one I want, and I need a slope, and that'll help me write the equation. So I'm just going to go with the first one. So I'm using this form, y subtract the y coordinate of the point I'm choosing, so in this case it would be 5, equals the slope I just found, x. Now it's already negative, and I need to insert the x that I'm using. Well, I'm using this x right here, and he's already negative. So that'd be negative 4, so I'm going to go ahead and make it plus 4. If we chose this x value right here, inside here would be subtract 8, and over here would be a plus 4 because our y coordinate is negative. Okay, so now I'm going to distribute, bring down y minus 5, negative 3/4 x. Negative 3/4 times positive 4 is negative 3. Now I'm going to add 5. Y equals negative 3/4 x plus 2. Okay. On this problem, it's written in point slope, so we just basically have to simplify it. So first thing I'm going to do is distribute on that right side. So y plus 6 equals negative times x is negative x. Negative times negative 7 is a positive 7. Subtract 6, subtract 6. Y equals negative x plus 1. Okay, that's all there is. Like I said before, this should be pretty easy. You should have learned all of this before. But if you have questions, always let me know. Your homework for this assignment is going to be a digital format again. It actually is shorter than the other ones. I think it's 18 points in total, 18 or 16, I can't remember. So make sure you watch the video and complete the homework. And if you have questions, let me know.